Okay, so your partnership with Centrica described, I think, as a major step toward multi-gigawatt on-site power deployment. What makes this moment the right one for such a collaboration? I mean, was it just coincidence, your particular driver forces, or just you've been talking for a while and made sense? Just yeah, give us some background.
I think it's the convergence of a new technology hitting maturity and scale and an acute market need. So obviously, I've known Centrica for a while, but became aware, particularly in the UK, that time to power was becoming more and more of an issue. I think I actually heard Chris O'Shea talking on the Today program about it. And I reached out to Chris and said, I think we've got a solution here. And um, what I did with Centrica is I actually took Centrica to some of our manufacturing partners in Asia, because what we do at Ceres is something called solid oxide fuel cells, and this technology has been around, for quite a while, but it's hit a maturity and a scale now, particularly through mass production in Asia, where it's now commercially available. So I took Centrica to the factories that were building this, and they saw this was real, and they thought this is very compelling, and it's compelling for a number of reasons. One is it's the most efficient way to turn fuel to power. It's modular. It's low to zero emissions. It's almost silent. And right now, you're waiting over 5 years for a gas turbine. Small modular nuclear is a decade away. You can't get a grid connection in the UK for love nor money. I run a company, a tech company, and we were told to wait 5 years by UK Power Networks for a connection. So literally, Centrica already had this issue, a backlog of demand, and we have a technical solution through our partnerships that can fulfill that.
Yeah, I mean, more recently, I've heard someone talked to the other day suggesting 15 years, but that's perhaps a little bit pessimistic, but it's clearly a long time.
It's a long time. I mean,
Yeah.
I'm being generous here, but even 5 years is too long, particularly when
Yeah.
you think that everybody wants growth, everybody wants sovereign AI, and all of this was before you layered on the demand for increasing data center power in the future. So that's it's only getting worse, shall we put it that way?
Yeah. Yeah. No, it's as you say, yeah, slowing down everything. Data centers AI, I guess, is the sort of headline sector at the moment. But it'd be good to understand, I guess, how Ceres solid oxide technology helps customers bypass the bottlenecks that are obviously there and accelerate speed to power, which yeah, again, I know from the data center space, that's time to market is the biggest driver out there at the moment, isn't it? So,
Yeah, well, I mean, what it enables is on-site power generation or behind the meter. So if you've got access to a gas connection, then you can generate power on site more efficiently than a gas turbine. So we're we're going from fuel in to regulated AC power out at north of 60% efficiency on site without any transmission and distribution losses, any of those things um, that are there. So that's really what the Ceres solid oxide technology enables. It's on-site power generation, and as I mentioned, it's got a number of benefits. If you can utilize the waste heat even in cooling through a chiller, then that efficiency goes up to 85, 90%. And then, on the data center side, there's another big emerging trend, which is fuel cells actually generate power as DC, and using uh, you know an increased interest in 800-volt DC architecture, so direct from fuel to compute. We're the most efficient way of doing that because you're literally coming off the fuel cell close to 800-volt DC and into the server racks. So you can eliminate a lot of intermediate transformers, standby power, standby generators in a single step.
yeah, and you've got, I think it's the SOFC and SOEC platforms. So one you could say is the power gen, and the other's the green hydrogen. So just give us an idea of. I think you obviously talked a little bit earlier on about the factories and the ramping up the expansion, but how mature or where are these technologies in terms of bringing to market or already being used?
Yeah, so Globally, they're being used in the US. So one of our peers, one of our competitors, a company called Bloom Energy, they've just done deals with the likes of Oracle, and several gigawatts worth of orders taken there. When we talk about our partnerships, we have partnerships with Delta Electronics, who are one of the big players in the data center industry, and their plans are to scale to hundreds of megawatts to gigawatts of production. With Doosan in South Korea, they already have a factory up and running. And then with Weichai Power, one of the biggest engine manufacturers in China, and Denso in Japan. So we operate a licensing model. If you're familiar with ARM in the chip industry, it's the same model. As a British technology business, we're world leaders in the technology, and we're scaling it with big manufacturing OEMs who bring this to market. You mentioned SOFC and SOEC. One of the beauties of this technology is it's reversible, so it can run in both directions. So basically, you're putting fuel and air together to generate electricity and a byproduct of water in a fuel cell. If you run that in reverse and you put renewable electrons and water together, you can split that into hydrogen and oxygen. It's the same cell that can do both. And some of our partners are actually looking at reversible systems that can run both ways in one unit.
And you mentioned obviously that the data center space is particularly sort of challenged when it comes to accessing power, and behind the meter solutions becoming increasingly attractive. But you also mentioned about that 800 sort of volt DC trend, and I think 1500 volts is even sort of further. So I suppose if you can just summarize how big you think the potential is for your sort of technology within that space, sort of now and in the future as the industry develops itself.
I think, look, the data center industry needs very reliable power. So it's quite cautious in adopting new technology. However, a window's opened up because conventional power generation from things like uh, generators, turbines, etc., is just not available. And what's happened is the cost of those has gone up to a level where fuel cells can actually enter the market. And as I mentioned, is already getting pretty mature. The benefits of this technology as a direct to DC technology is huge because you're saving something like $2,000 to $3,000 a kilowatt on the capex of a data center because you're eliminating some of that equipment in the gray space, and then you've got just the efficiency of it in terms of it's the most efficient way to take the fuel and generate the power on site. What the DC architecture, the 800 volt DC architecture is still, at an early stage. But if that proves out, it makes more sense to actually go with fuel cells rather than keep on using conventional AC generating equipment. So I think the market potential is huge. We estimate the market for SOFCs to be about 20 gigawatts production by the end of the decade. And that's certainly what our partners are starting to scale to. Each of our partners has multi-gigawatt kind of ambitions. And it's modular. So this can service small power loads like tens of megawatts up to hundreds of megawatts depending, you're just adding modules.
And in terms of, I mean, you mentioned the gas turbines, which a lot of people are using in the sort of short term, but I think they're saying that they're pretty much being used until such time as grid connections can be achieved, and then whether they mothball them or they use them in tandem with that. What's the position with what your technology is? That similar? So you anticipate it being used by companies for as long as they're waiting for a connection, and then they might still have it, but the connection becomes more important, or can you see folks running their data centers, reliably with your technology and not necessarily having to get that grid connection?
So this technology is prime power. It's not a standby or a backup generator. And like as I mentioned, it's more efficient than centralized power generation today. However, recognizing in the industry, if the power connection from the grid was available, the data center guys would probably prefer that, as a first solution. I think with this technology, you have a really good optionality because you could deploy this technology and in 5 or 10 years you can move it. It's modular. It's built of 100 kilowatt blocks. But as you get more confident with it, and the economics prove out, you just keep it. And it has so many other benefits that we mentioned, that actually I think once once fuel cells become familiar in the data center industry, I think they will get more and more widespread adoption.
And just back to the work you're doing with Centrica, I think you're supporting them across the full life cycle from the project origination, end of life recycling. So just the thoughts on that sort of service-led model, why that's particularly important when it comes to scaling the clean on-site power.
Yeah, look, what we thought the role we play in that, the supply and demand. So there's a clear need in the UK for this kind of technology. It's not just data centers, by the way; it's also commercial and industrial applications. But there's a clear need to bring this in. We have some of the highest power prices in the world in the UK, from these Asian suppliers that are using British technology. But obviously for Centrica, we're there as their technical partner, their advisor. We can help them, advise them on installations, customer education, all of those good things. But one of the things that we like about Centrica is they can provide complete power purchase type agreements. So they sell the gas, they sell the power, they can own and finance the assets. And that relationship is direct with our licensees. So we're not trying to say you must work with company X or company Y. That's Centrica's choice. But what we do is enable them to bring in this technology to the UK.
And I think I'm right in saying the partnership also touches on the hydrogen side of things and possibly integrating with Centrica's AMR program. So just your thoughts, I suppose, as to how SOEC technology can contribute to the UK's long-term green hydrogen ambitions. I mean, from what I understand, we don't really just have, hydrogen or whatever description available on sort of industrial scale, which is a problem. But so how do you think you can contribute to addressing that situation?
Yeah, so one of the beauties of this technology is it's fuel flexible, so we can run on natural gas today. So the first power generation units will run on natural gas. We can run on biogas and we can run on hydrogen. And as I mentioned, if you run it in reverse, you can actually generate hydrogen. And it couples very well with nuclear because we can actually feed this technology with heat, which makes it even more efficient. So when you have cooling off the back end of a nuclear power station or an AMR, you can then generate hydrogen extremely efficiently off the back end of that using an SOEC. So if nuclear becomes widely adopted as baseload power for a net zero future in the UK, this becomes a very economic way of generating baseload hydrogen as well, that you could put into your gas grids, or you could use for power generation, you can use for arbitrage, etc., storage. So it's that efficiency play. Solid oxide gives you the most efficient way to generate that green hydrogen as well.
Yeah, and maybe just, I mean, you might not want to comment, but just at this stage, it'd be good to get your thoughts. I mean, clearly it's a sort of complex landscape at the moment with all the different types of renewables, fossil fuels, and everyone's sort of pushing their own solution. And then there's these, as you say, the SMRs that people are getting excited about. But as far as I can understand, we're talking 5-10 years away before it comes on. So just your thoughts, I suppose, as to how you think this energy power supply landscape is going to develop. Do you think I mean, hybrid's the sort of word that people use with, almost everything. Do you think that's where we're going to end up with, or will there be an obvious winner, I suppose, over time?
I think there's going to have to be multiple tools used. I think, look, to hit net zero ambitions, we need more and more electrification, but we can't electrify everything directly. So again, using this technology, you can go from an electron to a green molecule to decarbonize industry, steel, etc. Also on that pathway to power generation, we need more and more electrification to drive things like data centers, etc. But again, if you can use a technology like this that can use existing infrastructure like the gas grid, but also biogas or in the future hydrogen zero carbon fuels, then it's a no regrets transition technology. And I think you're going to need all of this. I mean, even if you look at the power generation mix in the UK today, we still have gas playing quite a significant role in that, occasionally with peaker plants, etc. This technology is much more efficient than that centralized model and gives you that pathway to low to zero emission as well.
And you mentioned earlier you work with a global network of manufacturing partners. So is that already sort of enabling the deployment of the solutions at the scale and pace required? I mean, people are talking about these multi. I mean, we did a roadshow in Newcastle, and the power gen folks up there said current total area supply demand is about 6 gigawatts, and if all those data centers that are, okay, that's a big if maybe, but if they're all built, they're going to be 13 gigawatts, so doubling. And if that's happening all over the world, we're looking at sort of, I don't know, hundreds of thousands of gigawatt, whatever it is. But so just how well placed are you, I guess, and your partners to help address that huge, great growth in power demand?
Yeah, and I think that's one of the reasons we have the business model that we have. Because as a UK business, if we were trying to build everything here and scale it, the opportunity is vast, and it's not just the US, it's everywhere. It's here in the UK, it's in Asia, etc. The partners that we have, like Delta Electronics, are Fortune 500 businesses they have the capital, the cash to deploy, to build these global scale factories, and they're very good at it as well. So I think what we see as our model is we want to establish the Ceres technology, a British technology, as the industry standard, and we want to have a whole ecosystem of partners, a bit like Arm did in ships, using the Ceres platform, but the heavy lifting on the scale up, because you're absolutely right. If you look at the demand side, there's how accurate is it? We don't know, but even if it's half accurate, it's still a big demand that can only be fulfilled by scaling up of manufacturing and supply chains on a global scale, and that's why we have the model that we have.
And in terms of, I suppose, just to sort of finish up, ideas as to how you measure the success of whether it's the partnership with Centrica or just more generally the company's sort of roadmap and how you will contribute to energy resilience within the UK and it sounds like globally as well. So I suppose the question is, what does success look like for yourselves?
Well, like I said, I want Ceres to be the industry standard in solid oxide technology. And we believe solid oxide is going to be one of those key technologies that drives rollout of things like data centers, but not just data centers, behind the meter solutions over the next 5-10 years. We're just at the start of that journey today, and we've got this huge opportunity ahead of us. So success for us is we become that industry standard. We're very proud of being a British company. It's great to have a partnership with Centrica because we're very used to dealing with our Asian network, and we're looking to expand that network of manufacturers as well. But then it's also from a purpose-based motivation. We are very committed towards decarbonisation and bringing very highly efficient but clean energy technology solutions to market. So that's what drives us as a business. So we want to be a huge UK technology success story, but also with a really clear purpose, which is clean energy technology delivered on a global scale.
And maybe just finding, once you talk to folks and explain what you're doing, is it pretty much universally accepted excitement? Or I know the data center industry, haven't been in for a wee while, is quite traditional and for understandable reasons because,
Yeah.
uptime is the holy grail, and anything that there's not sort of had the tires kicked for a long time is maybe a little bit, viewed with a bit of suspicion. Do you get any pushback, or
Oh
because of
yeah.
the sort of predicament they find themselves in where they need power today and can't get it, they're more receptive to your kind of offering, or just how do you characterize the industry, I suppose?
I think you just hit the nail on the head. I think that it's quite a conservative industry, obviously, but they're more receptive to it because they need power solutions now. But actually, when you actually weigh up all of the benefits of this technology, um, then it makes a lot of sense. So we're just at that adoption, start of that adoption. And yeah, you do get some pushback, but I think what's happening now is when you see there's a big deal a couple of weeks ago announced by Oracle in the US where they actually cancelled the gas turbine order in favor of fuel cells. And the reason they cited for doing that was around permitting. It was water usage was becoming an increasing factor. Fuel cells use a lot less water than some of these other generation technologies. It's noise. People don't really want turbines in big urban centers. It's emissions. So all of those factors are major, major benefits. And then obviously the DC architecture, people just need to get comfortable with the reliability and the cost. Cost is coming down and reliability is being proven out. So I think once people are getting more and more exposure to this, and also they're following big names into, early adopters, then all of the analysis in the market tells us this has got a big potential for behind the meter solution.
That's brilliant. I mean, it's been great to chat, and it sounds like you're going to be extremely busy in the next few months and years to come. But thank you for sharing so many great insights into what it is you're doing and how the industry, well, data center industry, and obviously more generally, everyone who's looking at electrification, etc., is moving forward. So, Phil, appreciate your time. Thank you.
Great. Thanks, Philip.